HVAC zones define spaces that have common environmental or design requirements. Typically, the mechanical team will zone the building before running the heating and cooling loads. This is accomplished in Revit by creating HVAC zones. Zones consist of one or more spaces that are controlled by equipment that maintains a common environment, such as temperature and humidity. In this model, I have already created one HVAC zone in the south portion of the building. When I move the cursor around a space in the zone, you can see the space reference lines highlight. As I continue to move the cursor, additional reference lines highlight. These reference lines connect multiple spaces. When you see these web-like reference lines, they usually belong to an HVAC zone. You can verify this by looking at the tooltip or in the status bar. I can simply click to select the zone. With a zone selected, the ribbon changes to the Modify HVAC Zones contextual ribbon, and the Properties palette is populated with several parameters for the zone. I'll click in blank space to deselect the zone. Next, I'll select a space that does not belong to the zone. In the Properties palette, I'll scroll down to the Energy Analysis section. As you can see, the first parameter here is Zone. For this space, the zone is listed as default. When spaces are created in a project, they are added to the default zone. Once you assign a space to a zone that you create, the space is removed from the default zone. Now I'll select a space that belongs to the zone I created. Looking at the zone parameter, you can see that this space belongs to Zone 1. I'll deselect the space by clicking in a blank spot. Then I'll select the zone. Let's take a look at the parameters in the Properties palette. As you can see, numerous fields are read-only and are grayed out. These fields are not editable by the user, but they are instead calculated, or they reference other parameters in the model. In some cases, these parameters are populated by external analysis engines. In the Constraints section, the level is the base level on which the zone resides. In the Mechanical Flow section, the parameters are Calculated Supply Airflow and Calculated Supply Airflow per area. At the moment, these parameters are listed as not computed. They are also grayed out. These values can be calculated by the Integrated Heating and Cooling Analysis tool, or read from an imported GBXML file. They are simply the total supply airflow for the zone and the total airflow divided by the area. In the Dimensions section, the occupied area is the sum of the areas for all of the occupied spaces in the zone, whereas the gross area is the sum of the areas for all of the occupied and unoccupied spaces in the zone. Additionally, the occupied volume is the sum of the volumes for all of the occupied spaces in the zone, whereas the gross volume is the sum of the volumes for all of the occupied and unoccupied spaces in the zone. Lastly, the perimeter is simply the perimeter of the zone. All of the parameters in this section are calculated. In the Identity Data section, you can add any comments in the Comments field and also specify the name of the zone. The name must be unique for each zone. In the Phasing section, the phase is read-only and reports the project phase to which the zone belongs. The phase of the zone is based on the view properties for the view in which the zone was created. The phase of the zone must correspond to the phase of the spaces added to it. The last section is the Energy Analysis section. You can click in the Service Type field and expand the drop-down to specify the heating and cooling service for the zone. You can select one of the many available types in the list, or choose Building to accept the default service type for the zone. For the coil bypass parameter, you should enter the manufacturer's coil bypass factor. This is a measure of efficiency that indicates the volume of air passing through the coil that is unaffected by the coil temperature. The next three parameters all have edit buttons that open a dialog to specify additional information. For example, when I click the Cooling Information Edit button, Revit displays the Cooling Information dialog. Here, you can specify the cooling set point and cooling air temperature for the zone. Then you can select whether or not you want humidification control. If so, you can enter the dehumidification set point. I'll click Cancel to close the dialog. I'll click the Heating Information Edit button to open the Heating Information dialog. Here, you can enter the heating set point and heating air temperature. You can also choose to have humidification control, just as with the cooling information. I'll click Cancel to close the dialog. I'll click the Edit button next to Outdoor Air Information to open the Outdoor Air Information dialog. Here, you can specify the settings used to calculate the outdoor airflow for the zone. There are three options here: outdoor air per person, outdoor air per area, and air changes per hour. You can simply select the checkbox next to the parameter you want to specify. Outdoor air per person is the minimum amount of outdoor air required for each person for all spaces in the zone. Outdoor air per area is the minimum amount of outdoor air per occupied square area of all spaces in the zone. Air changes per hour is the minimum number of times per hour that the air volume of all occupied spaces in the zone is replaced. These three values must be specified for each zone. I'll click Cancel to close the dialog. The final 6 parameters are all calculated. Currently, these parameters are shown as not computed since loads have not been run or a GBXML file has not been imported. The main parameters are calculated heating load and calculated cooling load. These parameters are calculated by running a heating and cooling load analysis, or read from an imported GBXML file. Then the calculated load per area parameters are computed by the total load of the zone divided by the total area of the zone. Also, the calculated area per load parameters are computed by the total area of the zone divided by the total load of the zone. As you can see, Revit provides ways to keep track of heating and cooling load information regardless of whether the loads were run in Revit or exported to a third-party analysis tool and imported back into Revit.